In today's video, we're going to learn how to graph a rational function. On the left, I have a rational function, and then on the right, I would use that place to write a flow map as far as the actual process. Now, this is the process that I do. As long as you get to the end result, right, there's no set rules or route that you have to take. I personally like to start with the vertical asymptote. All right. The reason that is because I take whatever's on the bottom, set it equal to 0, solve for it. And then so x equals -2 will be right here. And again, the asymptote is a place where the graph is going to approach but not really hit. After I do that, I like to do my horizontal asymptotes. Remember, horizontal asymptotes is the same thing as a vertical, besides it's a horizontal line versus a vertical line. And I use one of these three rules. Y is either going to be equal to 0, it's not going to have an asymptote, or y equals a over b, where a and b are your leading coefficients. In this particular one, my degree degree of top is 0, degree of bottom is 1, so top is less than bottom. So top is less than bottom, so my horizontal asymptote is going to be at y equals 0. All right. The next things I do is, I look at my holes in the graph. Remember, a hole will occur if there are any common factors between your top and your bottom. And the answer is no, so there's no holes. The x-intercept is whenever y equals 0, and the y-intercept, remember, we let x be equal 0. So I like doing y-intercept first. So we would go y equals, again, this is y-intercept, 3 over 0 plus 2. And then so y equals 3/2 or 1.5. So if I zoom in, and then once I get this is going to tell me the shape of my graph. So it's going to look something like that. And then it'll just be reflected over and look something like this. Again, if I set my x-intercept, we set y equal to 0, so 0 equals 3 over x plus 2. We multiply those, cancel, and then 0 times x is 0x plus 0, anything times 0 is 0, 0 equals 3 is not true. So x-intercept does not exist, or you could say none. Continuous, right? Rational functions are not continuous because I don't have any holes. There are no removable points. I then finish up with domain. Domain of rational functions, negative infinity, until our vertical asymptote possibilities, which was -2, union -2 to infinity. And then I forgot to put range up here. But this will be from negative infinity to 0 because that's where my horizontal asymptote occurs, or from 0 to positive infinity.